Okay, hi, welcome everyone. We are currently doing H2 Math Supplementary Worksheet Chapter 9 on functions. Now, in this video, we are going to look at concept number 9, which is to sketch or try to visualize what is a piecewise function. Okay, so what is actually a piecewise function? It is a function which is defined by multiple subfunctions and each subfunction applying to certain interval of the main function's domain. Okay, so over here, right, we have smaller subdomains, and each of the subdomains we have different rules. Okay, so why is this useful? This is useful because sometimes we don't have a nice graph, right? So in order to get a nice graph, or more like we don't have a nice graph to model the real world situation, so what we'll do is we'll try our best to piece everything piece by piece, parts by parts, so that we can describe the model more accurately. Okay, so in this particular video, we are going to look at the objective of sketching the curve of piecewise function and also the curve defined periodically. Okay, so some helpful tips is we first need to determine the endpoints in each interval, okay, leaving a hollow or filled circle. And then what we need to do is we need to check the shape with the GC. Okay, something like that. All right, so let's take a look at example 9 on how do we sketch a piecewise function. Okay, so over here, right, what I will typically do is I will get my axis ready first. Okay, so that I roughly know what's going on. Okay, so getting my axis ready. So this is the x-axis. Okay, so over here is my y-axis. Okay, so first and foremost, what I'm going to do is now for 0 to 1. Okay, so between 0 to 1. Okay, so the function will have value of 1. So this is a constant function of 1. So it will be over here like this. Okay, constant function of 1. Now can equal to 0, can equal to 1. So I'm going to put a filled circle here and a filled circle here. Okay, so this is the first part. Okay, y equals to 1. Then for 1 to 3, right, correct, I'm going to sketch this graph. Okay, so the thing is when x equals to 1 over here, right, so this y is equals to, put in the 1 here, we will get 1 also. Okay, then when x equals to 3, put in the 3 here, y equals to 0. So I will have this point and I will have this point at 3 over there. Okay, so when x is equals to 3, right, I'll get this point over here. And what kind of graph is this? This is a quadratic graph, smiling graph, right? So over here, the minimum point is actually at 3. Okay, so something like this. Okay, so we've got a quadratic graph over here. And then otherwise, outside of this domain, outside this range from 0 to 3, there is a 0 graph. So it's a constant 0. Then here cannot be equal to 0. And then here can equals to 0. And then we'll just go here. Okay, like this. Okay, so this is the piecewise graph. So this piece over here, this piece over here, and then the 0 otherwise. Okay, so as you can see that we have a piecewise graph. So this is what we call a piecewise function. Now, so then again, right, let's take a look at the detail. Okay, over here, right, we can say that the graph is continuous because you can like travel from this path to this path without stopping. Okay, however, at this point, right, this is what we call a discontinuity, or this graph at this part is discontinuous. So what it means that from the left, it approaches 0, right? However, starting from 0 and to the right, it will be at 1. Okay, so there's a discontinuous part over here. Okay, so for us, we want to take note for, especially for this continuity, right? Now, where is the value of the curve? Okay, so when x is equals to 0, it will be equals to 1, right? So when x is equals to 0, right? So when x is equals to 0, instead of taking this point, we will take this point over here. Okay, so this is what what we need to be very sensitive. And if we don't take this point, we will leave a hollow circle here. If we take this point, means we are going to leave a filled circle over here. Okay, so this is the small detail that we need to take care for piecewise function. Okay, and like the skill for like the previous part also, we leave a hollow circle for the value of the function that we don't take. Okay, so like just now, like in the previous videos, right, we see that we can equal to 0, cannot equal to 3. We can equal to this value, cannot equal to this value. Okay, so something like that. Oh, sorry. Yeah. Okay, so this is the how do we find example 9? How do we sketch the piecewise function for example 9? Okay, so with this, let us move on to do it yourself 9, right? So this is a past year A-level question, okay, in paper 1. And what we do is we have a function defined periodically like this, okay, between 0 to 2 and 2 to 4. Sorry, piecewise, defined piecewise over here, and it is defined periodically over here, right? So this statement over here, right, tells us that this is a periodic function. Okay, so what are periodic functions? Periodic functions are functions that repeat itself in a certain period. And in this question, right, this 4, right? So the period of this graph is equals to 4 from this value 4 over here. Okay, so once again, where have you seen periodic functions before? So maybe I'll put a short note. So example of periodic function. Okay, so in AMAth, we've already seen that okay, for fx equals to sin x, right, what's the period of sin x? Is 2 pi, correct? So fx, right, is actually f of x plus 2 pi. Or actually is f of x minus 2 pi also can. Okay, in the same way, for tangent x, right, what's the period for tangent x? Period is actually 180 degree or pi. So it can be expressed as g of x plus pi or g of x minus pi also can. Okay, so this is how we write out what is the periodic function because the period is 2 pi. Okay, so something like that. Okay, so with this aside, right, let us evaluate what is f27 and f45 first. Okay, using the notion of the periodic function. Okay, so part 1. Okay, so what is f27? What is f45? Okay, one by one, f27. Okay, so 27, right? What I'm going to do is I will look at this. Okay, I'm going to look at period 4 first, right? So f27, right, is actually equals to f of 23 minus 4, right? And minus 4 again is f of 19. I can keep doing it, right, until I get f3. Okay, I can keep minusing 4 minus 4 minus 4 minus 4 until I get f3 because 3 plus 4 is 7 plus 4 11 14 19 23 27. Okay, so you keep adding 4, so all these values are going to be equal, right? And what is f3? When x is equals to 3, we follow 2x minus 1. So this one, it will be 2x minus 1, and the x over here will follow this 3. Okay, so what is 2 times 3 minus 1? So this value is 5. Okay, next one, what is f of 45? Okay, f of 45, same thing, I can minus 4. Okay, minus 4, right? I can keep doing it, right, until I get f1. And when x is equals to 1, right, when x is equals to 1, we will follow this function over here. So this will be 7 minus x squared. So this one answer is 6. So f27 plus f45, this is going to be equals to 5 plus 6 equals to 11. Okay, so this is the first idea about periodic function. Okay, now we need to sketch the graph for between -7 to 10. Okay, so what should we do? Okay, what we'll do is I will need to draw the main piecewise function first between 0 to 4. Okay, so let us do one by one. Okay, so I've put the function over here, right? So between 0 to 2, right, I'm going to put 4. Okay, then I'll put 6. Okay, 8 until 10, right? Okay, I'll just put there first. Okay, so I'm going to sketch from 2 to 4 first. So 0 to 2, right, will follow this 7 minus x squared. So when x equals to 0, y is equals to 10. So y is equals to 7. So over here, I'm going to start with 7 first. Okay, cannot equal to 0. Okay, next, what I'll do is when x equals to 2, sub in over here, y equals to 3. So I will have something like this over here. Okay, now this is a negative quadratic graph and it's centered at 7. So you get a negative quadratic graph over here like this. So this is the first part. Okay, second part, when x equals to 2, let's double check it and see whether is it continuous. X equals to 2, 4 minus 1 is 3, so we get this point over here. When x equals to 4, put in the 4, I will get back 7. Okay, so what I have is I will get back 7 over here. Okay, now this one is going to be a linear graph. Okay, this is a linear graph over here. So what we have is a straight line graph from 2 to 4. Okay, so something like that, right? And now because this graph is periodic, right? So what we're going to do is we're going to copy and paste and put this back. Okay, copy paste. Okay, a very simple act of copy paste. Okay, copy paste and put here. Okay, so let me erase this and erase that. So roughly, okay, adjust a bit. Okay, roughly this is 8, roughly this is 10. Okay, can all right. Then on the other side also we can copy and paste on the other side, so we get something like this here. Okay, and paste one more over here. Okay, and then let us see, this is -2, this is -4. Okay, this is -6. Now 7 would be over here, -7 is here. Okay, so when x equals to -7, right, it will follow this quadratic part, right? So put in the -7 here. Sorry, not put in -7. For -7, right, it should follow this part. Okay, it should follow 1. Okay, so when x equals to 1, okay, I think I'm being not clear. So f of -7 is equals to +4 plus 4. Okay, f1. And what is f1? Okay, f1 I'm going to put in over here. So this is going to be value 6. Okay, so when it is 7, right, this is going to be 6. Okay, and what I'll do is I will need to erase off the other part of this graph. Okay, erase off the left hand side part. So I'm going to get an incomplete graph on the left. And then this part over here is going to be -7 and 6. Okay, can equal or not? Okay, let's double check the question. Right? Okay, can equal to -7, can equal to 10. So over here, I'm going to start with a black circle and I will end with a filled black circle as well. Okay, so this is what we call a piecewise function defined periodically. Okay, the period over here is 4. Okay, this one, the period over here is going to be equals to 4, and then it will repeat itself for every 4 units. Okay, so something like this. All right, so we end the video here. So hopefully you've understand what it means when we want to sketch a periodic function, the easy periodic function, and what it means to sketch easy piecewise function, and what it means to sketch a piecewise function but defined periodically. And we need to know how to evaluate this lah. Okay, using the property of the piecewise function. So fx equals to fx plus 4 means that you can just +4 and -4, and then it will give you the same y value. Okay, so what we need to do is we just need to get the value to fall within this domain, and we evaluate from this domain itself. Okay, so that's all that we have for this chapter on functions. In the subsequent videos, it will be featuring how I handle the questions from other exam boards. So you go ahead and try. Right, go ahead and try, and you just compare your answer with these questions from other exam boards lah. Okay, I will go through manually on how do I do the calculation for this part. Okay, so that's all for this video. I hope and that's all for the concepts of functions. Okay, so hopefully this whole video series help you to understand what functions and what are some of the important concepts of functions. Okay, so that's all. Bye bye.